the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact. Welcome to the final session of the Fall 2023 Sustainability Seminar Series. As usual, we saved the best for the last seminar organized by the naming sponsor of the series, Hugo New Corporation. So it's a great privilege to have amongst us Robert Billett, who will talk about environmental law, corporate accountability, and PFAS contamination. I'll introduce Dominique Wickenhoff from Hugo New, and then she is going to introduce Rob, as well as Mark Yagi from Waterkeeper Alliance, who has kindly agreed to join us, and he's here today. So many of you know Dom already. She is like a regular feature in our seminar series, and she manages the Hugo News sponsorship of this seminar series. Dom is the Senior Vice President of Corporate Affairs and Sustainability at Hugo New Corporation. She leads the company's global efforts in corporate sustainability, health, safety, and environmental initiatives, public and community affairs, and green business growth and investment. Prior to joining Hugo New, Dom served as a senior advisor to the EPA Region 3 Administrator. Dom has an MS in microbiology and biophysics, and she was the National Science Foundation Fellow. All yours, Dom.
That's good. So thank you, Divs, and thanks, everyone. We're very excited. Divs just mentioned my EPA career background, and I was mentioning, I hope everyone's just a plug for the book, Exposure, read it. I read it and realized how old I am because I was recognizing some of the names. Incredible, arduous journey. Just can't say how fearless and courageous, Mr. Billett, you were in this journey that now we're all on, thanks to your incredible work. And we're just so delighted to have you here. And to that degree, before turning it over to you to hear whatever you want to talk about, because I know it's this big, but you're the one that knows exactly where things are now, and we want to learn. I'd like to introduce Mark Yagi, who's CEO of Waterkeeper Alliance, which is an international, it's all international, includes our U.S. river keepers and water keepers, many of whom I've worked with in my career with EPA, who are the champions and protectors of these incredible, important water resources. And it was my pleasure over a year ago to assist in peer reviewing a very groundbreaking study that Waterkeeper Alliance pursued and reported on, which was monitoring PFAS in many of the nation's water bodies, rivers and streams through the river keepers. And Mark, I'll turn it over to you to say a few words on that groundbreaking study and where we go from here, because as well as the results that you found. And thanks for being here.
Oh, thank you so much, Dominique and Dibs and everyone. I'm grateful to be here and appreciate all you do for our waterways and our planet. And you gave a little background about Waterkeeper Alliance. I think some of the attendees might be familiar, if they're from the metropolitan, New York metropolitan region, might be familiar with our groups like Hackensack River Keeper or New York, New Jersey Bay Keeper or Hudson River Keeper or Raritan River Keeper, Long Island Sound Keeper, and so on. They monitor and patrol your waterways day in and day out to protect your right to clean water and hold polluters accountable. And it's a great honor to be here with Rob, who also holds polluters accountable. I think it's safe to say that no one's done more than Rob to shine a light or bring a light to the toxic threat that PFAS have on human health and the environment, as well as exposing the corporate bad actors that are exacerbating the threat. And as you mentioned, Dominique, his terrific book Exposure is a really captivating account of that incredibly difficult and complex work in exposing PFAS, and encourage, like you did, everybody to read it if you haven't. And the end of the movie Dark Waters, and Rob really put PFAS on the map. So it's a pleasure to be here with you, Rob. You can't attend a water conference these days without one or more sessions being focused on PFAS. And I'm confident that, without Rob's instrumental work, our organization's work on PFAS wouldn't be what it is today. And I'll just give a brief snapshot of that work that Rob has inspired, that you mentioned, Dominique, as we were kind of looking at different ways to attack the PFAS issue through our network of water keepers, and realized that there's a real lack of data about PFAS in our nation's surface waters. And so in the summer of 2022, we partnered with local water keeper groups across the United States to test 114 surface waters for 55 different types of PFAS. And the results unequivocally showed that dangerous PFAS pollution is widespread in surface waters across the country. Essentially, 83% of the 114 waterways we tested across 34 states in the District of Columbia were found to be contaminated with at least one type of PFAS chemical. And given the limits on how low you can test for PFAS, I'd argue fairly comfortably that the other 17% are probably contaminated as well. You just can't test down that low yet, or we didn't test, they were outside the 55 we were testing. The Hackensack River had the highest results in the waters we tested in New Jersey, so close by where you are. Some of the places we tested in New York and Pennsylvania had levels that were thousands to hundreds of thousands of times higher than what EPA experts say is safe for drinking water. Now, we were testing surface water and not tap, but 65% of Americans get their drinking water from surface water. So there's an analogy there. And the testing resulted in a report called Invisible, Unbreakable, Unnatural, and it gave the locally based groups compelling data to inform their communities about PFAS, investigate the sources, and advocate for change. And it also gave us a clearer picture of the data nationwide to advocate for change and set us up for the next phase of sampling, which right now we're starting with partners like the Hispanic Access Foundation and multiple local waterkeeper groups to monitor for PFAS contamination in surface waters from wastewater treatment plants and associated sludge application sites in environmental justice communities, with the idea being using environmental justice screening tools, PFAS discharge data, and other EPA data to identify high priority sewage treatment plants in these environmental justice communities and deploy state-of-the-art passive samplers, get those to a lab, get the results, prepare and disseminate a report, documenting all the methodology and the findings, and use that to generate public education and advocacy materials to support, regulatory and legal requirements and permits, as well as prioritizing, this infrastructure funding to get those high priority plants cleaned up, and really identify and act on opportunities to work with municipal governments to advocate for source controls. And, Rob was really instrumental in putting us on that pathway, and I'm really looking forward to hearing what he has to say. I know the one thing that's driving me crazy about PFAS right now is that EPA is coming up with drinking water regulations for PFAS, which is a good thing. We want to get it out of our drinking water, but we're all going to pay for it as ratepayers. And there are no limits on the discharges coming from the estimated 30,000, industrial discharges of PFAS in this country. They're dumping into the water that we're then paying to clean it out of to drink. So I don't know if that'll get touched on today, but I'm really looking forward to it. Thanks for the opportunity to say a few words.
With that cue, I think, Rob, we want to hear from you. So, Mark, appreciate that. I don't think I need to provide any more, background in terms of the incredible litigation work. I wrote down unregulated contaminant monitoring program. I just want to mention for the audience out there, these chemicals were not regulated. Though industry knew of the impacts, the adverse impacts, but it was literally unseen, in fact, to a large degree. And so, as Mark mentions, more monitoring. If you can't measure it, you can't address it. If you can't, detect it, it's hard to figure out how to go from there. So very important. But with that, it is my honor to introduce Robert Balot. Thank you.
Thank you. Thanks so much, everybody. I really appreciate the opportunity to talk with everybody this evening. Thanks, Mark, for all the work you're doing. As I think we'll touch on a little here later, this unfortunately is going to continue and going to continue for quite some time. So, what we're going to talk about is, as you heard, PFAS, per and polyfluoroalkylated substances. This completely man-made class of chemicals. There could be thousands of them at this point. And these are chemicals that we're now finding in the water all over the planet, the groundwater, the drinking water. We're finding them in the soil. We're finding it in plants, in wildlife, in the air, and we're finding it in the blood of almost every living creature now on the planet. And these are chemicals that we're all starting to hear about over the last couple of years in particular. There's a lot of activity now going on, trying to get to the point of whether we actually begin regulating these chemicals, restricting them, which ones should we be identifying. There's a lot going on right now. And it's almost impossible to avoid hearing about PFAS now, particularly those that are in the environmental field. Yet these are chemicals that have been out there for almost 70, 80 years. These are chemicals that were invented around the time of World War II and have been pumped out into the world ever since then in massive quantities, to the point that we now have contamination on a global scale that's pretty unprecedented in scope and scale of what we're dealing with now. So how did that happen? How in the world did we get to the point where we've got these completely man-made chemicals that never existed on the planet prior to the time of World War II? How did we get to the point where we've now got these things permeating virtually every corner of the world, including our blood and the blood of our children as they're being born? Yet we're still grappling with, what are these? Where are they? How are they used? What is the toxicity of them? And unfortunately, what we're now all beginning to learn is it's been known for a long, long time that these chemicals were incredibly toxic, persistent, bioaccumulative, some of them carcinogenic. Yet we're all just starting to learn that now, and we're all sort of trying to play catch up to get to the point where we begin restricting that. So I'd like to spend a little bit of time this evening to just kind of explain how we got there, why we're still in the position we're in right now, and where things are, I think, likely heading here going forward. I'm a lawyer, so I have to make my little lawyer disclaimer at the beginning. What I'm going to tell you about is my own personal observations and opinions over the last couple of years. I'm not speaking on behalf of any client or my law firm. But I began my legal career, 33 years ago, 1990. And when I graduated from law school, I started working for a law firm in Cincinnati, the Taft Law Firm, where I'm still at over 33 years. That's where I'm talking to you from this evening, is from our Northern Kentucky office. And at the time, I had graduated as a political science, urban studies, liberal arts undergrad from college, no scientific training whatsoever. Then I went to law school and had taken a course right at the end that was talking about environmental laws. And so when I started out my legal career, knowing nothing about what lawyers did or what different types of law were, our law firm that made me an offer to begin working for them had an environmental group. So really not knowing what that was, other than, hey, that was an interesting class, I joined that group in 1990. And for the next 8 years, I really kind of learned what our whole legal system was for dealing with the environment. In other words, the rules and regulations about what can go out into the air, what can go into the water, what can be put into landfills. And I spent about 8 years learning that whole system, the state rules and laws, the federal rules and laws, the acronym SOUP, of Clean Air Act, Clean Water Act, RCRA, CERCLA, TSCA, all these acronyms of all these different federal laws, international laws as well. And I thought, frankly, that by the time I'd been doing that about 8 or 9 years, and I was actually becoming a partner at the law firm, that I thought I understood this pretty well. A lot of what I was doing was working with big corporate clients, a lot of big chemical companies, helping them navigate this. And we had a pretty, I thought, impressive system where we had these state and federal laws, rules, and regulations that said, here are the nasty things you need to be worried about that go out into the world. The toxic chemicals, the hazardous chemicals, the clean air contaminants, the clean water contaminants. We had lists that told us, here are the things to be worried about, and here's how much of them you need to be worried about. And we had federal agencies that had been created to help implement all of that and tell us which ones were a problem and to set those numbers and rules. And so as long as we were doing what we needed to do to work within that system, we were doing what I had been led to believe was the right thing to protect the environment. Well, my whole perception of that world changed when I got a phone call one day, October of 1998, and a gentleman on the other end of the line started telling me about cows dying on his farm in West Virginia and that I needed to help him. I was about to hang the phone up at that point because that's not what I did. I had no idea why he was calling me. I mean, I was working for big chemical companies. I was helping them get permits to put things into the air, the water, the landfills. I was about to hang up the phone and he said, your grandmother told me you'd help. So I paused to figure out wait a minute, what's the connection here? And then he explained he was raising cows on property outside of Parkersburg, West Virginia. And my dad had been in the Air Force, so we moved all around. But my mom had grown up in Parkersburg. Her whole family was there. So family holidays, birthdays, we always had gone to Parkersburg. So kind of saw that as my hometown. So here's somebody calling from my hometown, the recommendation of my grandmother, I'll listen. And what he started to explain to me was that he had these animals that he and his family had been raising for generations on property that his family owned along the Ohio River. And next to his property was a landfill permitted by the state of West Virginia as a non-hazardous, just regular old trash landfill. And over the last couple of years, he'd been seeing white foam starting to come out of that landfill and flow into a creek that ran through his property. And that's the creek that his cows drank from. And over the last couple of years, he'd been seeing more and more white foam coming out of that pipe into the creek. And the more his cows stood in that foam, drank that stuff, he started to watch them get sicker and sicker. They were developing tumors. Their teeth started turning black. They started wasting away. No matter how much he would feed them, they just didn't gain weight. And they eventually started dropping dead. And by the time he called me in 1998, he'd lost over 100 animals. And it wasn't just the cows. He was seeing impacts to the deer, the fish, the other wildlife in the area. And to him, this was pretty obvious what was happening. There's something in this white foam coming out of this landfill that was making these animals sick. But nobody would help him, he said. He had called the state EPA. And the state said they had pulled the permits and looked at everything and nothing really was exceeding permit limits. Everything seemed okay. He had called the US EPA and heard the same thing. And then he said he'd called the company that owned the landfill. And at that point, he identified that company as DuPont. Now, at the time, DuPont, I knew, was one of the world's biggest chemical companies. Now, yes, we represented a lot of big companies, including chemical companies, but DuPont wasn't one of them. But I did know them because one of the things I was doing as a lawyer was, this was back in the 1990s, there was a lot of what we called Superfund cleanup work going on all across the country. There was a federal law that made everybody who had sent waste to these dump sites responsible for cleaning it up. So everybody would get together in a room, lawyers for all these different companies that might have sent waste to a site, and they'd all get together and fight about who has to pay how much to clean up these sites. So for years, I've been in these meetings representing our clients, and typically A lawyer for DuPont would be there because DuPont, as this big chemical company, had these sites all over the country. So we didn't represent them, but I knew them. They had some of the best lawyers. I knew they also had some of the best scientists on the planet. So when I heard that this problem, which seemed pretty obvious, was happening out of a DuPont-owned landfill, was permitted by the state, I thought, oh, we should be able to help this gentleman. After all, this is what I do, right? I help companies get permits to run landfills just like this. So I said, why don't you bring whatever you've got, come on up to our offices, we'll take a look. So he and his wife got in the car, drove up to Cincinnati, and they showed up armed with boxes of VHS tapes. Now, some of you may be too young to remember those, but this was the day of VHS tapes. So we started watching these videos that he had taken, dating back to 1995, 1996, and photographs, and watching all this. And what I saw in those videotapes, which, by the way, those of you who've seen the films Dark Waters or Devil We Know, you see videotape of this farmer's cows when he's cutting into them. Those are scenes from the actual videotapes that we watched. They incorporated them into the movies. Anyway, we're watching that. And so after looking at all this and hearing what was going on, seemed pretty obvious. Hey, there's some clear, obvious problem here. I should be able to help this guy. After all, I mean, I help companies get permits. We should be able to get to the bottom of it. So we agreed to take that case on in 1998. And I started doing what I typically did for other big company clients. I called the state of West Virginia. I called the US EPA. I got all the permitting documents. I started looking through it all. Nothing was jumping out. Just like the agencies had said, there was nothing that was clearly exceeding some regulated permit limit. There was nothing that would explain what was causing the foam or causing the impacts on those animals. And we eventually brought a formal lawsuit against DuPont. And at the time, who said, oh, we'll work with you. We'll give you all of our permitting records, or everything that's regulated in that landfill, we'll give it to you. So I've been going through their records as well. And again, nothing was jumping out. And so it finally occurred to me that everything we were focusing on was what was regulated under the landfill. So I eventually decided, wait a minute, I just need to know what all is in that landfill, whether it's regulated or not. And I need to know, where is this stuff coming from that's going to this landfill? So I sent DuPont what I thought was a fairly innocuous request. I said, hey, I want to know everything that you're sending into this landfill, whether it's permitted or not, and where's it coming from? What's being made at whatever plant you're making this from? At that point, we got a lot of pushback from DuPont, and they said, oh, no. This is going way beyond we can give you what's regulated, but you're going into things that are irrelevant. We don't need. Long story short, we had to go to court. We got a court order to force this information to be turned over. And as I started to go through those documents, what I saw there changed my whole perception of what I thought I understood about our world of regulated chemicals and protecting the environment. Because here's what I saw in those documents. And again, those of you who've seen the films, you saw those boxes coming in. That's the way it really happened, because these were the days before everything was on computers. It was all paper. So I'm reading through all these papers and documents, and what I see is this. There is a massive amount of a chemical in that landfill that is incredibly toxic, persistent, bioaccumulative, carcinogenic, but it's not regulated. It's not in the permits. And it could have the capacity to not only cause this foam, but to do the kind of damage we were seeing here. And when I'm first seeing all this, and I see this reference to this chemical, I don't pay much attention to it, because what I see is a reference to something called PFOA or APFO, which means absolutely nothing to me at the time when I'm reading this document, because I'd never heard of that. And I went to my list of all the regulated hazardous chemicals, toxic materials. This stuff's not on any of those lists. So I'm seeing all this discussion about this chemical that's in the landfill. And I thought, well, it must not matter, must not be bad because it's not regulated. It's not on any of the lists. So I didn't pay much attention. But then I started seeing more and more documents about this same chemical. And the more I started digging in, the more disturbing was the information I was seeing. Because what this was showing was, even though this was a chemical that wasn't mentioned on any of the permits, what I saw was this. This was a chemical that had been invented by the 3M company up in Minnesota, right around the time of World War II. 3M had invented this way of connecting carbon to fluorine atoms, which, again, I didn't understand why that mattered or what significance that had, other than I had some experts, our big our chemical company clients were using, that I sat down and talked to, and they helped explain what all this meant. What they said was 3M had invented this way of connecting carbons and fluorine that had never occurred before. There was no natural organic fluorine like this in the world, but 3M had created this way of making these chemicals. It created a chemical bond with the backbone of this carbon fluorine that was incredibly strong, made it very useful for various manufacturing processes, but it was a chemical bond that was not going to be easy to break apart. It would stay together. And 3M had invented two of these chemicals in particular that had 8 carbons with a fluorine bond, C8s. One of them was called PFOS, and that was a chemical that 3M had invented and was using in some of its own products like Scotchgard. And in later years, a type of firefighting foam used to put out petroleum fires called aqueous film forming foam. They brought out in the 60s. And then there was a second chemical with 8 carbons called PFOA. And that chemical, they were selling primarily to another company, DuPont. And what I saw here was DuPont was buying that chemical to use in making one of DuPont's signature products, Teflon. And what I saw as far as the timing here, DuPont had started purchasing the chemical from 3M as early as 1951 and started really using a lot of it by the early 1960s, because that was the point in time where DuPont was starting to launch the Teflon product, frying pans and all of that, out into the world, into consumers. And so they started getting this chemical in the 50s and 60s and knew, hey, we're going to be putting this into a product that's going to go all over the world. Now, it's very important to keep the timing in mind here, because in the early 1960s, the US EPA didn't exist yet. The state and federal laws and regulations that I had been learning about, the Clean Air Act, the Clean Water Act, the Hazardous Substances Act, all of these lists, those didn't exist. Those started to roll out in the 1970s. So this is before that. Yet, so these regulatory agencies didn't even exist. But when the DuPont scientists started looking at this, they had some of the best scientists on the planet up in a lab called the Haskell Laboratories in Delaware. And they started looking at this, and they were very concerned about this strong chemical backbone, this carbon fluorine bond. And they started saying, well, if we're going to put this out into the world, what's it going to do if it gets out into the environment? What is it going to do to living things? So they started doing toxicity animal studies in as early as the 1960s, looking at how does this chemical impact living things? They started tests on mice, in rats, in guinea pigs, in dogs, in monkeys. And they were seeing multiple adverse effects in multiple species. So red flags started going off. This is the 1960s. And then in the 1970s, what I'm seeing in these documents, a bigger red flag goes off. That's when people were starting to put fluoride in the drinking water across the country for cavities. Well, some researchers had gone out to see, hey, I wonder if that type of fluoride's getting into people's blood, since we're putting it in drinking water all over the country. So these researchers had gone out and collected samples from US blood banks looking for that type of fluoride, and they found it, inorganic fluoride. But they also found something they weren't expecting and were very surprised about. That was organic fluoride. And at that point, this is 1975. These researchers are looking at that saying, I wonder where that's coming from, because that's not what we're putting into people's drinking water. And they did some research, and the only thing they could find was references to some of these patents by 3M for making these perfluorinated chemicals. So they approached 3M in 75, 76 and asked them, hey, we're finding this stuff in the general population's blood. Could it be yours? And the documents that we later discovered in later years show that 3M tells them we pled ignorance, all right? But nevertheless, their own research confirmed, yes, it was their stuff. And in fact, they started then sampling their own workers and finding this was getting into the blood of humans who were working with it. And not only would it get in the blood, it would stay there and persist and build up over time. So they alert DuPont, which is purchasing PFOA. This is in 1978. DuPont starts sampling its workers and seeing the same thing. So at 3M and DuPont, alarm bells are going off because not only is the stuff toxic, they're now finding that if people are exposed, it's going to get in their blood. And there's a concern because this chemical behaves differently than other chemicals. It doesn't get rapidly excreted like other stuff does. Like if I'm drinking my coffee here, this caffeine will be gone in an hour or two. And it doesn't just deposit to fat or to one organ. These chemicals, when they get in you, they get into your blood and they kind of stick in the blood. This is a lawyer talking, of course, excuse my terminology, but they then circulate throughout the body and coating all the organs, behaving like a ticking time bomb, all right, as this stuff stays in the body. So that's what sent off real concerns. So then the companies say, well, what about the long-term effects? We better look at cancer. So they start cancer studies in rats. And by the early 1980s, the first cancer studies done of the chemical that DuPont's using, PFOA, they find the chemical causes testicular tumors, all right? Not just might be linked with or associated, but the companies say it's causal. This stuff causes testicular tumors in rats. So at that point, what I'm seeing in all these documents is DuPont's concerned because, wait a minute, we're using massive quantities of this chemical at our plant. And they've got this massive, big Teflon manufacturing facility right up the road from the farmer's property in West Virginia, the world's largest Teflon manufacturing facility. And their concern is when we use this stuff, it gets emitted up into the air from the plant smokestacks. That flows directly toward Ohio. And we're discharging it directly into the Ohio River with no filtration of any kind. And we're taking liquid sludges and dumping it into unlined pits around the property. What if this stuff's getting out into the surrounding community? So they go out and they actually secretly collect samples of public water systems in 1984 from both Ohio and from West Virginia. And yes, they find PFOA that has gotten into the water in both Ohio and West Virginia. And then you see this, I'm seeing this discussion. What do we say about it? Do we tell anybody? Now, at this point, you may be thinking, well, wait a minute, the EPA exists, right? I mean, the EPA came into existence in the 70s. The first laws governing chemicals and chemical testing had what you have to disclose to the EPA had come out. Well, that's true. The Toxic Substances Control Act, 1976. But this, when those laws rolled out, that's when all this blood data was going on, was being collected. And the companies were trying to decide, what do we do about this? Well, when the laws came out, they really focused on new chemicals from that point forward. For existing chemicals that were already out there, like PFOA and PFOS, the law essentially said it was up to the companies making and using these to alert the EPA if there was some substantial risk to human health or the environment, such that they ought to go back and look at them. So what I'm seeing in these documents is as all this information's rolling out, the companies are looking at that and they're choosing not to tell the EPA. And so by the time this data comes out that it's toxic, persistent, it could be carcinogenic, it's in the public water, the EPA and the state agencies don't even know this stuff's out there. So when the company's finding it in the water, there are no state or federal guidelines because the agencies don't even know it exists at this point. So, but the DuPont scientists say, we need to know what's the safe level. So they actually sat down in 1988 and became the first people on the planet to calculate what would a safe drinking water level be for this chemical in water. And the number they came up with at the time, particularly based on the persistence and the bioaccumulation, no more than 0.6 parts per billion. Now, we're all talking parts per trillion now, but it's important to keep in mind why that number was significant. The lowest level you could detect using the analytical methods DuPont had at the time was about 0.6 parts per billion. All right, so they were essentially saying, if you can detect it, we're concerned. They took that number, they rounded it up to 1 part per billion. And what did they find in the public water supplies? 5 to 6 times higher than that. And then I finally had figured out what happened to the cows. Because what I saw going on was when the company was finding, oh, we've got this and it's higher than these internal levels, they thought we can get rid of this problem because we suspect it's getting into the public water by seeping out of these landfills. All the sludge is seeping out of these unlined pits and getting pulled into the public water supplies. Let's dig all that sludge up and this will go away. So in 1988, they had dug up 7,000 tons of PFOA-soaked sludge. Well, then they had to take it somewhere. Well, they had this permitted landfill from the state of West Virginia for non-hazardous waste, completely unlined landfill. Well, at this time, of course, this is non-hazardous because the agencies don't even know the chemical exists. So they took the 7,000 tons and dumped it into this unlined, non-hazardous landfill. Then what does it do when the rain hits it and this chemical hits the water? It foams. And DuPont had actually gone out, and I'm finding in these documents, they had sampled the water in the creek 1 year later. And what did they find? Remember, their internal standard was no more than 1 part per billion. They found 1,000 parts per billion in the creek. And there were notes speculating what would this do to cows. So needless to say, when I saw all these documents, I had a pretty good idea of what had happened to these cows. So I made a phone call to the DuPont lawyers. We settled the case for the farmer pretty quickly. But at that point, we realized we had a much bigger problem here. This chemical was in the drinking water of the public water supplies. Nobody knew about it. Nobody had been told. And it was at levels that were above what the company itself had calculated as being the proper standard. What do we do about that? So looking at all this, my perception was this was a massive public health threat. We could have tens of thousands of people that have been drinking this who had no idea. Government agencies had no idea. So I sat down and put together a letter that went to the US EPA, the Department of Justice, the state EPA, everybody I could think of, laying out what I had seen in these documents, the non-confidential documents, about the fact, hey, this chemical's out there, it's getting into public water, it's above the level the company says is appropriate, something needs to be done. That letter was March 6th of 2001. And spoiler alert, I know a lot of you already know this, we are just now, 22 years later, getting to the point where the US EPA has said we will take steps to regulate that chemical in drinking water. Hasn't happened yet, but we're almost there. So why? Why this delay? All right. So that letter goes out in 2001. And when that does, the community finds out for the first time it's in the drinking water. So they came to us saying, we want help getting it out. What's it going to do to us in the long term? As lawyers, though, that presented a real problem. It wasn't regulated. What federal or state guideline could we point to that was being exceeded? So we ended up filing a case on behalf of the community, alleging that the levels exceeded what DuPont itself said was proper. And so that case got filed in 2001, eventually became the first class action in the country for everybody in the community that had this in their drinking water. I started also trying to provide as much information as I could to the US EPA and other government agencies about what I was seeing in these internal DuPont documents about the health threat, the rat studies, the monkey studies, the human studies. And I started funneling that information to the government agencies. In 2002, the US EPA announced, based on looking at this information, we're going to do a priority review of this chemical. We may need to take steps to ban it under the federal laws. And in 2003, they actually created their first risk assessment, looking at the fact that what would this chemical possibly do to the population? Because EPA had finally found out that the chemical not only was in the water in West Virginia, but that it had been found in the blood of the entire US population. Even though the companies had known that in the 70s, the EPA didn't find that out until much, much later. So when they found that out and did their first risk assessment, there was real concern that the margins of exposure between safe levels and dangerous might be a little too low. So in 2004, US EPA actually sued DuPont, saying, you withheld information from us that you should have given us a long time ago. And if you had, we might have being able to begin regulating this a long time ago. 2005, the Department of Justice even initiates a criminal investigation into all this. So when all this finally starts to sort of blow up, that's when DuPont decides to resolve all this. They settle the case with the EPA. They pay them a small fine. They also agree they'll stop using any more of this stuff by 2015. Over the next 10 years, there will be a phase out of PFOA. In the meantime, 3M had already said, we're out. We're not gonna make the C8s anymore. So DuPont finally then agrees, because DuPont had jumped in at that point. All right, when 3M stopped making it, DuPont thought, well, we'll take over that market. We'll start making PFOA. So they had been making it down in North Carolina. So anyway, they eventually agreed, we'll phase that out over the next 10 years. So they settled all the government cases. And then they had to settle our case in West Virginia. They agreed to a settlement there where everybody got water filtration systems, granular activated carbon, ancient technology that had been around forever that could have been put on decades ago. So that filtration went in on the public water supplies, in-home systems were designed for people. But then we had to address the bigger question. Can this chemical actually cause harm at the level these people were exposed? Because that had been the big fight throughout the case. We had seen all these animal studies, and we kept hearing from the company, well, it's irrelevant because it's animals, it's not humans. Even though that's why you're doing the animal studies, all right? Then, so we started pointing to the worker studies. And we were hearing, well, maybe they've got increased cancer rates too, but they're highly exposed. And that's not a big enough sample size. You can't draw valid conclusions. You don't have big enough data. So when we settled the case with DuPont, we knew we needed to somehow address this gap of what's enough data to actually show this chemical can cause harm here. So we sat down and agreed that we would do something nobody had ever done before. We'd create a science panel of 3 independent epidemiologists, human health study people, who would be allowed to look at all the existing data and design new studies specifically focused on one issue. Can the exposure at the level these people are drinking it in their water, at their dose, all right, can that actually cause harm? Human disease. And we defined the group to be studied by their dose level. People who'd been exposed to 50 parts per trillion or more of PFOA for a year or more. And you may think, well, where did 50 parts per trillion come from? Remember we talked about 0.6 being the lowest level back in the 80s? Well, by 2005, when we're doing this, 50 parts per trillion was about the lowest you could quantify it in the water at the time. So we define this group by their dose level. We give these scientists the right to do these new studies. Well, then we also used $70 million in cash from that settlement to pay everybody in the class who was willing to come forward and provide a blood sample and access to their medical records so that we could actually have enough data, a big enough study group to actually confirm whether this chemical was linked to disease. Because what we were hearing, for example, was particularly with cancer, which was one of our main concerns from the early rat studies, you need tens of thousands of humans before you can actually draw conclusions about cancers. The worker studies, they're only a couple hundred or a couple thousand. They're just not big enough. So we needed lots of data. Well, nobody had ever done this either before, with offering people and seeing. We got 69,000 people who came forward and provided blood and access to medical information. All that was turned over to this panel. That panel then spent 7 years analyzing that data. They designed 12 massive new human health studies, some of the biggest human health studies ever done on any chemical. And again, it took them 7 years, from 2005 to 2012. So during this period of time, the chemicals showing up in other places. For example, in Minnesota, they say, wait a minute, that chemical in West Virginia, wasn't that made up here? And Minnesota went out and started sampling, and sure enough, they found the chemical in the water in Minnesota. And we tried to help the community in Minnesota and in New Jersey. The state of New Jersey realized, wait a minute, that same stuff, some of that waste was shipped to a plant here in New Jersey called the Chambers Works. Has that gotten out into the Salem Canal and all these other places? Well, they start sampling, and sure enough, they find it in New Jersey as well. So we bring a case in New Jersey. back in 2006. Well, in these new cases, what we're hearing from everybody is, well, the science isn't certain yet. We've got this science panel that's still looking at it. So in Minnesota, they actually start moving forward. They adopt some of the first state rules and regs on these chemicals. New Jersey does as well. I know some of you here in the audience are very familiar with what New Jersey has done beginning in 2006, really some of the leaders in that. So this stuff's moving forward. And in the meantime, though, we're being told the science is uncertain because the science panel hasn't spoken yet. Well, in 2012, the science panel finishes, and the science panel comes out with reports that confirm drinking this chemical in water is linked with 6 different diseases, one of which testicular cancer, the very same cancer we'd seen in the rat studies in the 80s that we were told it was irrelevant to humans. So testicular cancer, kidney cancer, ulcerative colitis, thyroid disease, preeclampsia, high cholesterol. When those findings come out, a whole cascade of events begin. Number one, everybody in that community, they get free medical monitoring under our settlement. A whole new medical monitoring program is set up for the whole community. Thousands of people sign up. People that actually have one of those diseases are allowed to then move forward with their individual claims against DuPont for damage. Somebody that got cancer, for example, is then allowed to move forward with their claims. We had 3,500 people in that community come forward with one of those claims. So those cases start moving forward through the court system. And we actually got to the point of finally bringing the very first case to trial against DuPont in 2015 for a lady who'd been exposed to this chemical in her water and got kidney cancer. And we got a verdict. All this history was laid out, a verdict against DuPont. DuPont was liable for having caused cancer in the lady who drank the water. 2 more trials, both also verdicts against DuPont. This time also punitive damages. Juries finding the company acted with conscious disregard of what was known at the time. In the middle of the 4th, DuPont settles them all for about $670 million. Then we settled more a couple years later for another $83 million. So about $750 million in settlements. But that's just this one community in West Virginia. The rest of the country still isn't really paying any attention, with the exception of some folks in New Jersey and in Minnesota. The rest of the country still isn't even aware this is going on. Well, a lot of that changes in January of 2016 when an article comes out in the New York Times Magazine that lays out this whole story and, importantly, points out this chemical in the water in West Virginia, it's likely in the water all over the country. Because what was going on is once those links with disease were confirmed by the panel, I had sent those to the EPA saying, okay, what else is needed to move forward with drinking water standards? And it was at that point that the US EPA, for the first time, puts PFOA and PFOS, the C8s, on the list of unregulated contaminants for public drinking waters to begin sampling for the first time. This happens 2013, 2014. So public water supply starts sampling for the first time, and they're finding PFOA and PFOS. That information's going into EPA. I'm seeing it on the website. But the public isn't becoming aware because it's not regulated, all right? So anyway, this New York Times article mentions that. Hey, this stuff's being found all over the country. So you suddenly have people all over the US in 2016 saying to the EPA, hey, what's the safe level for this? Remember, our letter had been in 2001 asking for a safe level. So 4 months after that article comes out, the US EPA comes out with its very first long-term exposure guideline for PFOA and PFOS in drinking water, no more than 70 parts per trillion combined. Now, that has a huge cascade of effects, in particular with the US Department of Defense. Because what happens is that when the EPA sets the numbers for those 2 chemicals, people realize, wait a minute, these chemicals weren't just used in Scotchgard and in Teflon and at these 2 factories in West Virginia and Minnesota, maybe in New Jersey. Those 2 chemicals were also used in one product in particular that's been used all over the world and used in a way that's likely sprayed it all over the place. And that's this firefighting foam I mentioned, aqueous film forming foam. PFOA and PFOS were used in this firefighting foam since the 60s. And how were people told to use it? You spray it out all over the ground. All right. And unfortunately, although the people making the chemicals knew this stuff was in the foam and knew how dangerous it was, they weren't telling the people using the foam. They weren't telling the military personnel. They weren't telling the firefighters. So this stuff had been shipped out to every military base, every airport, every fire station, and spewed out all over the place. So the Department of Defense realizes this stuff's likely in the ground outside military bases all over the country. So beginning in late 2016, early 17, hundreds of sites start getting sampled, and you start getting this data rolling in. And around that time, what you start to see happen is communities all over the country start realizing these same chemicals are in our water too, and they're likely at levels above what the EPA is saying is safe. Well, then you see this whole new wave of litigation. Cities, counties, municipalities all over the country saying, wait a minute, we now might have to put in filtration systems, and we might have to incur incredible costs to try to deal with this stuff. Why, we didn't create this. So they start bringing claims against the PFAS makers and the foam makers, hundreds of cases. States start bringing claims. Minnesota was the first for claims for contaminating the fish and the natural resources. Other states jump in. Then you start having thousands of individuals saying, wait a minute, I think I might have been made sick. I'm a firefighter. I was bathing with this stuff all over me. Nobody told me I have cancer. So thousands of new cases are getting filed. And as all of this is happening, the science is evolving. And over these next couple of years, what we start to see is that there's more and more concern about how toxic these C8s are. And particularly, we're finding effects at lower and lower exposure levels. And the types of effects are increasingly of concern, particularly immune system impacts, even the potential to impair the ability of our bodies to respond to vaccines while COVID's going on. So we're finding, here we've got something that's in the drinking water all over the country, might be in the blood all over the country, has this kinds of effects. So regulatory authorities start digging back into these numbers again. And what we see happen just last summer, US EPA came out and revised its drinking water guidelines for those chemicals. They took them from 70 parts per trillion down to 4 for PFOA. All right, and then they said we are going to move forward to actually set enforceable maximum contaminant levels under the Drinking Water Act. And our goal is now 0, given that they are considered carcinogens. So we see this dramatic lowering of the acceptable levels. And while all of that's going on, by the way, International Agency for Research on Cancer, just a couple of days ago, internationally came out with the same finding, saying PFOA needs to be elevated now to the highest category of carcinogen, category 1. That was just a couple of days ago. So we now have pretty much...
Rob, sorry to interrupt, 5 more minutes.
Okay. So we now have almost uniform consensus on the scientific side about the threat of these. But in the meantime, what's happened as those start getting phased out, the C8s, people say we're not going to make those anymore. But the world starts to realize those aren't the only ones. While those were phased out during that 10-year phase out, the companies that were making them started tweaking them. Instead of C8s, they started making C4s, C6, or they added carbons, C9s, C10s. And suddenly we started to realize there are thousands of these possibly out there. How do we address this whole group? And what you start to see are regulatory authorities and scientists say, we need to approach and deal with this whole class. The European Union, just last summer, then announces, we think we need to ban all PFAS. So we see this, we go from concern about this one chemical in one community to concern about that chemical nationwide to suddenly concern about the whole class worldwide. And the more dramatic, reflection of that is we just see after that, the inventor of these chemicals, 3M, which had for decades been saying there's nothing wrong with these, there's no threat. They came out and said, we are going to agree to stop making all PFAS by 2025. So as this has finally sort of evolved to this point where we're now looking at all of these chemicals worldwide as a threat, we now are ending up with this big battle, which is not only, what's more important here, the economic impacts of regulating these, because regulating this big group will have impacts. They're in all kinds of products. They're everywhere. But they also have severe potential public health threats and costs. How do we balance those? And most importantly, and I'll end on this, who pays for all of this? And that's the battle that's going on in courts right now, all over the country and now internationally. And for some of us who've worked on this from the very beginning, that should be an easy answer. Because when you find these chemicals in the water, in the soil, in wildlife, in people, they are fingerprints back to a couple of companies. These do not exist in nature. So they are fingerprints back to the companies that made these. And so a lot of this litigation that's going on right now is to make sure that the people who actually created these and kept pumping this out, knowing this was going to happen for decades, that those folks actually end up having to confront these costs, and that those costs don't get pushed onto the victims, the public, the governmental entities. And so this is also, and this is where I'll leave it, creating a huge opportunity for scientists and engineers who now have to figure out, not only once somebody actually does start to pay, how do we get rid of this? What kind of technologies will exist to clean it up? So with that, I appreciate the opportunity to be here. I'm happy to take questions. Sorry I went long, but thank you for the opportunity to talk to you this evening.